All right, here we go. So M&Ms claim that 15% of all M&Ms are brown. I've heard that before somewhere. Suppose you got a bag of 78 M&Ms, 18 of which are brown. Is there evidence that their claim is underestimated? Okay, state. For the state, we need four things. We need a ho, we need a ha, we need an alpha level, and we need to define what the true proportion is in the problem. And what is the original claim in this problem? 15%. Okay, now this is hard. This word underestimated. Is that greater than or less than or not equal to? No. Okay, underestimated means that you suspect that it's a bigger number than this. The meaning this is under.
So the number that we have underestimated.
Yes, exactly. So that's why we're doing it, because there's weird translations sometimes. E equals the true proportion of brown. I can't draw the ampersand, so I'm just gonna go with this weird E with the dots. I don't know what that's called, but it's not an ampersand. If you can draw the ampersand, that is great. I cannot. And alpha, it doesn't give us one, so we use 0.05 as a happy middle ground. Okay, other than the word underestimated, which is the spicy bit of that, are there any other questions about the state before I move on?
Nope.
Okay. Plan. Well, let's see. I only have one sample of M&Ms, so I'm thinking this is a one sample. Z test. And why is it a test and not an interval? Well, because it's asking me about evidence, which is a yes or no answer, which is a test. And it doesn't tell me to do a confidence interval. So for P. Random. Okay, it doesn't say anything about randomness, but I just sally forth. So assume 78 M&Ms is a random sample. Check. No, it's not. It's just a weird E with dots. 10%. N equals 78 is less than 10% of all M&Ms. Do we think that that's a safe statement? Do we think there's more than 780 M&Ms in the world? I think there's probably more than 780 M&Ms in the Rayleighs and Benicia. Okay. Large counts. Okay, so large counts is your first little bit of special nuance. Remember, we should do n times p, and this is the only time that we actually have a p to use. So 78 times 0.15 is greater than or equal to 10. 78 times 1 minus 0.15 greater than or equal to 10. Do you guys know where I got these numbers from? Okay, 11.7 and 66.3. And I'm going to come back in and highlight these 0.15s because I want you to have the little connection that I got those from the null hypothesis, not from p hat. Okay, any questions about the plan? Okay, do. All right, for the do, I'm going to find my yellow sheet, which seems to be buried for a second. Okay. Do. Do the do. Okay. Standardized test statistic in this problem is Z. That's because it says it's a one sample Z test equals. Okay. Statistic is the proportion from the sample. So over here off to the side, I'm going to find the sample proportion of browns, which is 18 over 78, which is 0.23. Is that okay with everybody where I got that from? Then you guys know hat means sample, right? Okay. So statistic 0.23 minus parameter 0.15. You guys know where I got that from? Okay. Over standard error of statistic. Okay, so then we go, bam, we turn our sheet over and we say, okay, standard error of statistic is this for one sample, 0.15, 1 minus 0.15 over 78, which is definitely a number that I forgot. It's 1.98. Okay, now real quick, this is one of the spots where I don't want to just assume that you know how to type it in. Do you remember my advice about typing this into the calculator? Yeah, so I said type the top, hit enter, and then divide it by the bottom. Or you could put parentheses around the top in the calculator if you want. I find it easier to just hit enter. Okay, now Jedi mind trick. Take a look at 1.98 on the z-score back here on the big magnet poster deal. Do you think that's far enough in the tail for us to be able to reject the null hypothesis? Yeah, I think so. Because if you add up the things from the bottom, it's just going to be 2.35 times 0.05, right? No, what I'm talking about? No? Okay. So, oh, I forgot to write what I'm finding. Okay, now my first period class, they didn't ask me while I was teaching. They asked me when they were doing the problems themselves, so I want to head it off at the path if possible. Don't feel like you can't ask, but 1.98 would be like right here, right? Here's the 2, so like 1.98 would be right there. Okay, so because you're on this side of the curve, that means you're working with this tail, the tail to the right. Okay, anytime that you get a positive Z, you're working to the tail to the right. Okay, but what does that mean for normal CDS? It means that this is the low and positive infinity is the high. Okay, so our low is 1.98. High is 10 to the 99, 0, 1. Would be really helpful if I could find the one I did earlier because I could steal the numbers. I just want to steal the numbers. Okay. Equals 0.024. Okay, for my visual folks, I'd like you to come back and highlight those 0.15s so you can see where all three of those numbers match each other. Okay, last bit. Since our p-value of 0.024, can you guys stop, please? Is it less than alpha or greater than alpha? Less. That's good, right? We reject the hoe, which means we get to do a little party on our paper. We found something. We made a discovery. Woohoo! Okay. We have convincing evidence that, okay, and you can do two things here. You can write the ha in words, so the true proportion of brown M&Ms is greater than 0.15, or you can scroll up and answer the question in the problem. This one, the answer to the question in the problem is shorter, and I'm lazy, so I'm going to say convincing evidence that M&M's claim is underestimated. If you don't like that, you can just write the true proportion of brown M&Ms is greater than 0.15. Okay, now I'm going to ask you a couple of questions just from the rest of the chapter to check for understanding. Okay. Now, if we reject the hoe in this case, we found that the true proportion of brown M&Ms is greater than 0.5. What does that mean for like the manufacturing process? What does that mean? Yes, too many browns. There's a machine going haywire, perhaps, just spewing the brown M&Ms into the population. Just somebody gave the brown machine like a Red Bull, and it's just going to town making brown M&Ms. I don't know, possible. Okay, so that's what you're saying. Not really the Red Bull part. I'm just trying to make you smile. Okay, however, are we sure? Are we 100% sure that from one sample of 78 M&Ms, we can conclude that an entire factory is working improperly? No. What type of error might we have created here in this problem? Type one. Type one. Okay. With the type one error, we might have concluded that there's more brown M&Ms than there should be when there actually isn't. And then we just got a wonky sample with a lot of M&Ms in it. Right? Possible. So remember, hypothesis test is inconclusive. I mean, you could make, a conclusion, but no, it's possible to have a type one or type two error. Okay, last question. What would be the advantage of, instead of doing this, doing a confidence interval for this same problem? What would be the advantage of, instead of doing this, doing a confidence interval with the same problem? Yeah. You can have associate frames where the actual amount is false. Yes, I could not have said that better myself. Not only would it give you a yes or no answer, but it would also give you a plausible range of values for what the brown proportion is. So you get extra info. That's why the confidence interval is better than the hypothesis set. But in research, they still use them both. So, we have to know. Any questions about this problem before we move on? Okay, now we're going to go to the other side and we're going to do the left one and that one too. I'm going to warn you that you need to write small. Yeah, I mean, not like tiny, but like I wrote. Like, take a look at my size of writing here. Yes. Okay. A sleep foundation, and this is kind of a weird problem, and I'm glad we're doing it together. Anyway, a sleep foundation studied a random sample of babies' sleep habits. The sample was stratified by region and gender so that an equal number of boys and girls were studied. Of the 995 sampled, 37% of babies woke up to eat at least once a night. Split into two age categories, 39% of the 811 babies under 6 months old woke up to eat at least once a night, compared with 26% of the 184 babies 6 months or age 6 months or older. Is the difference of 13% real or just natural fluctuations in the sample we've chosen? Let's hope it's real, just for all those sleep-deprived new parents out there. They're really hoping that their babies will stop waking up in the middle of the night. I feel it for that. Okay. Staked. We need 4 things. We need the ho, we need the ha, we need an alpha level, and we need to say something about context. And is it okay with you that because the under 6 months babies were mentioned first and the over 6 month babies were mentioned second, that I put P under 6 months minus P over 6 months equals 0? Do you guys understand where I got those letters from? Under and over. Perfect. Okay. Now this one is not saying anything about is it greater than or less than. It just says, is the difference real? So it's saying, is there a difference? Wait. I did it again. I did this first period too. I made that mu and it's supposed to just be a u. I'm so used to writing mu that okay, no alpha was given, so I'm going to use 0.05, and then I'm going to say proportion under minus proportion over is the true difference in proportions of babies who woke up at least once a night. Poor little sweet, adorable babies. So many of them. 811 babies. Yes.
In the homework, you were putting you wanting P2 as separate definitions and not P1 minus P2. Is that like
Either way.
either way?
Yeah, I just find this to be faster, so I do this. Just make sure if you're going to do this, is kind of like, that's kind of like your Camry. This is kind of like your Corvette. Just make sure that you say difference if you're going to list it like this. Okay, did I get all of the state things? Yeah. Plan. 2 sample Z test for P1 minus P2. Random. Okay. Now they're supposed to be separate random samples. And this one is a little weird. So there's some weird stuff about this problem. The first weird thing is that they actually took the survey in one big sample, but they must have put it on a spreadsheet or something and then like split the data into 2 pieces. Can you tell that by the way that it's worded? It's stratified. Yeah. So this word means that they were separated by region and gender. So I'm not going to say stratified. I'm just going to put separate random samples. If you want to, you can put this little note just so that you can recognize that word again later if it comes up. I don't know that it comes up again. This particular problem, as I said, is weird. So I'm happy we're doing it together. Okay, 10% condition is not weird. 811. Okay, do you guys think that it's safe to say, yes, honey?
Can you not experiment?
It's not. It's an observational study. I don't think you would want to poke the babies to wake them up. I have to agree with you though. When I see the word stratified, my brain goes directly to experiment. Okay. Uh, oh, as I was saying, do you think it's fair to say that there's more than 8,110 babies that are under 6 months old? Probably. I also think there's probably more than 1,840 babies 6 months or older. Just imagine them all in one room or something. Adorable, cute little wearing clothes stuff. Okay, large counts. Okay, large counts is weird for two samples. I'm gonna pull out my yellow sheet here. For large counts, you need to use p hat c for your p. And I don't know if anybody noticed, but they gave us p hat c in this problem. I've never ever seen a problem give you p hat c before. Okay, first of all, do you know what p hat c is? Do you know what that means? P hat c. Pooled proportion, yeah, pooled proportion. So that means all of the babies that woke up divided by all the babies. And they gave it to you in the problem. Can you guys find me the percent of total babies that woke up? 37. Okay, I do not suggest that we skip this step though, because I feel like you're never gonna actually have that. So we're just gonna pretend we didn't see that. Okay. How many babies woke up in the first sample? So I'm gonna go to the calculator and go 39% of 811. That's 316 babies. Okay, and 26% of 184 is 48 babies. Over 811 little babies and 184 slightly older babies. And guess what this comes out to be? 0.37. Okay, but I just wanted to remind you how to find p hat c. And I don't think there's ever a problem where they give it to you again, but tell me if you find one. Okay, so n times p hat c greater than or equal to 10. N times 1 minus p hat c greater than or equal to 10. N times p hat c greater than or equal to 10. N times 1 minus p hat c greater than or equal to 10. And this is 296.8, 67.3, 514.2, 116.7. Joke. Look at all those conditions. So many conditions. Okay. Any questions about the plan before we move on? Take a look, make sure you know where all these things came from. Could you recall them from memory? Maybe not, but we're working on that. Okay, I'm already more than halfway down my page. Okay, so do standardized test statistic is Z equals. Okay, and the statistic is P hat. Okay, so I'm gonna find it over here. P hat U minus P hat older. I really should have scooched that over. That's okay. What was the proportion of babies that woke up under 6 months? Yep, 0.39. What was the proportion of babies that woke up over 6 months? And then here's the next weird thing about this problem. They actually gave you this number too. Yeah. Okay. So statistic is the two decimals subtracted minus parameter. Parameter is the null hypothesis number. Okay. And then standard error is that big one on the back right here. Okay. How unusual is this sample? Yeah, it's off the chart. 3.3 isn't even on there. That means they're definitely going to be able to reject the null hypothesis. Okay. All right. So I know it's awesome. Okay. However, there's a thing with that too. Okay. So I'm at 3.3. I want you to be able to look back here during the test. Like you let this thing help you. 3.3 is right here, right? Okay, you're on this side, the right side of the curve, which means that you're going this way. Does that make sense? Yeah. Okay, so what would be the low? 3.3. What would be the high? Yeah, infinity, positive infinity, right? Okay, now I want you guys to see what I get when I do this. I don't want that. Okay. Okay, look to see what I get. Does that make sense? Because it's teeny tiny, right? The area of that spot would be teeny tiny. You have two options here. You can write the scientific notation answer, which is what I'm going to do, or you can move the decimal 4 spots, 1, 2, 3, 4, and put 3 zeros in front of that. I'm going to write 4.67 times 10 to the negative 4. My big ask is that do not put e negative 4. It makes you sound uneducated because that's the way a calculator puts it. That's not how human beings write the numbers down. Okay, now, does anybody know that I'm not done with the p-value here? Oh, no. Okay, what do we do when it's not equal to? multiply by 2 because it's saying it could be the tail on the top or the tail on the bottom. Okay, so times 2 and just go times 2 in the calculator and now you have 9.33 times 10 to the negative 4, which is still a teeny tiny decimal. So it really didn't affect your ability to reject the null hypothesis, but it would if it was higher number. Yep, yep. These three numbers right here are all to the negative 4. Oh, new parents everywhere can rejoice. We found convincing evidence that they will stop waking up. And when they get to be, I don't know, 17 or so, they'll probably avoid you instead of waking you up. I don't know. Those days are really fun when your kids need you for everything, though. Super cute. Okay, so there's some stuff to remember. Don't forget about p hat t. And don't forget that when it's not equal to, you have to multiply by 2 at the end. And don't forget that if it's positive, you're doing the right tail, and if it's negative, you're doing the left tail. Okay, so we're gonna work on the other two. I do have a joke for you. I feel like it's pretty great. And the homework isn't bad, I don't think. Because a bunch of people started working on it first period. Here is my joke. It says, I can't believe schools are still teaching kids about the null hypothesis. I remember reading a big study that conclusively disproved it years ago. Like there's a different one in every problem, so you can't just Can you believe how many stats jokes are out there though? It's all about Pinterest. Hmm.